In last few years, we have been seeing a lot of research in modulation formats, other techniques for enabling 100 gigabit per second transmission. Now that particular technology has been commercially viable, has been shown to be commercially viable, the next challenge is to move it to the next level. So I believe in this conference we will see papers on even higher speed communication per wavelength channel, which will include 400 gigabit, and then moving forward to ideas for 1 terabit per second channels. So that's one area. The other thing which I believe will happen in this conference is an interesting development of revolutionary ideas to be able to scale the capacity to even 10x or 100x over what we have today. And this will require new ideas on the optical side, such as space division multiplexing, multi-core fibers. So we are beginning to see some publications on those fronts as well, which will be included. These are exciting. The other trend which I think we are noticing on this particular at this conference is that some of the ideas of 100G technologies, such as the coherent detection, are also being considered for access space, which is traditionally is a very low cost technology area because products have to be really cheap. But coherent could play. People are now exploring that architecture in the access space. So these are some of the trends I'm looking forward to at the conference.
So the biggest trend I think I saw for Category 8 optoelectronic devices is really in the quality of the papers. And I think two topics that, a few years ago we generated just a few papers in each one, but have really become major are coherent communications and 100 gigabit Ethernet. So very, very high speed communications. We have 2 sessions on coherent and 100 gig links this year. And silicon photonics. So that's also been a very fast-growing area where just a few years ago it was a couple papers here and there, and now we actually have 2 dedicated sessions on silicon photonics as well. So those are the 2 that really jump out. I think the nice thing about optoelectronic devices is you always get a great variety of really interesting and novel components that people submit to OFC. And they're different every year, but across the board. So we have high-speed modulators, we have new VCSELs, we have new CW and tunable sources, we have high-speed photodetectors. You name it, if it's an optoelectronic device, it's covered in OFC. And so it's an exciting program this year.
The main challenge that service providers are facing is taking the cost out of the network, providing different services, and that's why it's also interesting to look at different architectures. Inside the network, there's many ways to do different functionalities. And I think this conference will provide a good overview of many different groups on how they tackle these situations and these new technologies, the new types of convergence. And that's why I think it's going to be interesting for service providers to come see this conference. NFOEC has a much shorter focus. What you're going to see is shorter term demonstration, test beds and things. And therefore, for service provider, I think this is the most attractive part of the conference. It's not research that is 5 years, 10 years out. It's really short-term demonstrations that are going to impact decisions, help service providers make decisions. So service providers can get a good view of all the latest developments and demonstrations and shape their networks, their technologies, and build all the different types of services that they need.
The workshop we're offering through optoelectronic devices is called Photonic Integration, More Technologies and Applications. And it has a provocative title, and it's designed to be an exciting and hopefully a little bit, not combative, but I guess lively workshop. Because it is designed to pit, different technologies and have their champions talk about their strengths and maybe admit some weaknesses, but it should be a good discussion.
Very exciting things are happening in device work all over the conference. Some standout examples are transmitters that now work with direct modulation at 70 degrees C at 40 gigabits per second. That's a new world record. There'll be exciting topics on receiver technology. There's one particular case, there's a 100 gigabit DQPSK monolithically integrated receiver, which is another milestone in the industry.
In this area, optical networking in general, it is changing. So we are looking at like new modulation technique, how it will reduce the, it will improve the spectral efficiency, and also we were looking at like high power lasers, especially as we are moving to different type of modulation speed and longer distance, those areas. And the biggest thing we should be looking, or we will be looking at, is the green energy. I mean, how to reduce the power of our network. Power consumption of our network is very important.
Another highlight I would also like to add is the RAM session on is green networking revolutionary. I think it really poses an important question right now. We have many research programs worldwide coming up with green technology research in general, and on the other hand, people are saying, are we doing it anyway in our research, so is there something new to it? And exactly this RAM session will address this discussion, and I look forward to it very much.
I think another really exciting thing this year is going to be the rump session on Tuesday night, where people will talk about green technologies. Are they really green, or are they just repackaged? And there'll be quite a good free-for-all that I think will be very exciting for people to see on green technologies.